I wouldn't want you to look at all these independent bands, but I would want you to look at this composite, you know. Let us zoom onto it. And when I zoom onto it, no, at some point you will see that this image breaks out into pixels. Okay, and that exactly is the structure of any satellite data or any raster data, I should say. So what exactly it is made out of these pixels, several pixels, and these pixels are essentially square in shape. Okay, their shape is square. It has side measuring to a length of a, and all the sides it is going to be a. Okay, whatever that length is, let's say if this is 30 meter, if I want to find out what exactly is the length of this, so what I will do, on this horizontal bar you will see this measure line. There is this one tool that reads measure line. Okay, so even if you press on to control shift and m, then this particular tool will open up. So I'm taking it, it opens a panel. Let me tuck it to side, and then let me click. You see the cursor has changed into a plus sign. So I bring that cursor over one corner of this pixel, click there. Now you will see that the values will start showing up here. You have to look at the total. Okay, and I bring it to the second corner. Okay, and I see what is the length. It is 29.904 meter. That means almost 30 meter is its side, correct, no? So if I want to know what is the area that this one pixel is representing, then it is 30 into 30. That is how we find the area of a square, correct, no? Side into side, correct, no? Side square, that is the area of any square. So this is 30 and this is 30. So 30 into 30 comes to how much? Can anybody do that for me? How much is the area that is represented by this one pixel? 30 into 30 comes to 900. Correct. Okay. Yes, for the landlocked regions also, we will use the same bands for now. Okay. So this is 30 into 30, 900 square meter it is. It is 900 square. Think of, even if you want to purchase 900 square meters, such a huge area it is, correct? No, it's a huge area. So within this area, if at all there is any change, then I'm not able to see it. You understand the problem here? What is this pixel doing? It is not helping me in understanding within this pixel, that is within this 900 square meter, if there is any distinction, that I'm not able to see that heterogeneity. Now to make that concept a little more clear, let me bring up this Google satellite image. Okay, look at this Google satellite image. So I'm coming here, look at this particular pixel. Okay, look at this particular pixel. Let me check it off so that you will be able to see the Google satellite image. Let it load. Seems to be loading. Loading only, no? Yeah, it is loading. It will take a little longer until it loads to that zoom level. Okay, now let's turn on this composite layer. It's somewhere here, you see this. Okay, so within this pixel, look at this particular pixel. Within this area, you have different things. For example, there is this road, then there is this vegetation, there is some open land also there, mud is also there. But then this pixel is not giving me that information, which means the amount of reflection that is coming from this region, it is getting averaged out, and that average value is something that I see for all this entire region. Understood what I'm saying? which means even if I was to zoom out and look at the composite image, it is, this part is not really giving me true representation of what is at a finer scale. It has its own scale. Now let me try zooming out, and then you know that here you see more of regular pixels of the similar color tone. So here it is essentially completely vegetation, and that is why they are similar. Whereas wherever there is a drastic change between the kind of land use land cover, there are different types of pixel that are there. Okay, so this is something that we have to keep in mind whenever we are using any satellite data. We have to know for at what scale we are looking at the data set, and what is the scale that is going to yield better to us. For example, if I am trying to study entire district, Landsat 8 will be wonderful data. But if I'm trying to study a small property, maybe somebody has purchased some 8,000 square meters of property, then I might have to go for a drone image. That is why people go for investing into drone images, no? Otherwise satellite data would have also worked, but then satellite data has limitations in terms of its spatial resolution. So what is spatial resolution? It is the size of these pixels. What is spatial resolution? It is the size of this pixel. So this pixel has a size of 30 meter by 30 meter, that is 900 square meter. Within that, any different any heterogeneity is there, then we are not able to perceive it. Okay, so that is the structure of the satellite data. Now let me right click and go to the properties and come to source. No, information. We will come to information. So here you will be able to see what is the width in terms of meters that this is, in terms of height, and what kind of data type it is. This is unsigned integer 16. You can read it here, unsigned integer 16-bit data it is. Okay, what is 16-bit? 2 raised to 16. Okay, what is 4-bit? 2 raised to 4. So 2 into 2 into 2 into 2, that gives you the number of range of value that is present within that particular satellite data. So the format is gtif, and there are multiple other things, band 1 specifications, band 2 specification, and all these things, which particular coordinate system it belongs to. It belongs to this WGS 84 UTM zone 43. So all this information, that is the metadata, okay, also gets loaded within this particular composite band. So right now we have used only band 1 to band 4, and that is why this is how it appears. But we can also use more bands, that is band 1 to band 7 also we can use, band 1 to band 9 also we can use, band 1 to complete band 11 as well we can use. We can do all that thing and make a composite. Later I will send you one more exercise that you have to complete. Okay, based on this band composite, and looking at the metadata of that band composite. All right, let us save this project. My screen is not visible, it's visible now. Okay, let's save this project so that we don't lose on to whatever progress that we have done.